Okay, well, welcome everybody. My name is Luke. I know very little about CNCing, but I know enough to cause problems. And so hopefully I will teach you some things that you might not know. And really, this is going to be an open discussion for everyone. If you have questions, jump in. Uh, Feel free, like interrupt me, that's totally fine. There's also a lot of other people I notice on here who also know a lot, probably more than me. Um, so I'm sure they'll be able to jump in and help out, which is cool. Quick overview of today is safety, 3D coordinates, software, and hardware. Like, gonna go through things like as a general overview. We're really gonna focus on the software side and the hardware and the G-code interpretation using Mach 3, because those are the big ones. Safety, really simple. Don't be stupid. Very simple. And then a whole bunch of other stuff that actually matters. Safety glass is mandatory. Things are dangerous. They spin. Really, the most important thing is like work holding or like securing your workpieces. If you don't do that properly, it's going to get damaged. You're going to get damaged. It's just not going to be a good time. And then the other thing is cutting materials. Don't cut carbon fiber because it's just going to put a ton of like really bad things into the air. There are ways to cut it. Like some people use like CNC routers and cut it like in a water table, like in a plastic tub full of water. But I would say probably not ideal because we have such a shared space and we don't really have the ventilation or anything for that. So really, if you're going to do things like that, just ask the CNC committee. That's what we're here for. Make sure the materials are approved. Like any wood's going to be fine. Plastics are generally going to be fine, depending on what you're doing. And yeah, check those things before you wreck everything. And then other important thing is it's really easy for the machine to machine into itself. So check your G code pretty carefully before executing it. We do have limit switches and things, but that is not something you want to be relying on, really. And then any repairs, calibrations, maintenance, CNC router, don't do them. Just talk to the CNC committee. Unless you've been approved to do so, which if you are confident and you want to get involved more, we are more than happy to onboard people to help out. Because the more people we have helping out, the more the machine's going to be running, the better time we're going to have for everyone. And that goes for all the machines. So this is the wooden CNC router we have at VHS, which I've been building for the last like 4 or 5 years. And the basics of 3D coordinates are for any milling machine or CNC machine or 3D printer. You have your X, Y, and Z axis. For us, on this machine, I'm not sure if you can see my mouse. Anyone?
Yep, I can see it.
So basically, Z axis is this one here. X is across, so this longitude axis here, and then Y is this long one all the way to the end. So this would be what it kind of looks like in Mark III, I think. So we have our X across, Y here, and Z. And the other important thing is your Z height is the origin point for your workpiece is when you're machining down, you're always machining into a Z negative space. So your 0 point for like when you're setting up your work holdings in Fusion, you want your Z to be pointing up away from your workpiece and you want to be machining down. I used to forget that all the time and sometimes still do. And then I start machining upwards and things are just all backwards and it's bad time. So yeah, just usually for us, like this Y plus, X plus, and Z plus, these three would be this left corner here on the CNC over here. That's our homing position for this CNC. And the other CNCs will be similar. Some of them will be in the back right corner, the back left, depending on where the homing position is set up. But for this machine, it's going to be over in the bottom left, per se. And then your Y positive and your X positive will be all the way in the back corner. So that would be your coordinates. And then your Z Your 0 point for the Z will be the limit switch at the top, so it'll be where it is there. And that will be the machine 0 point. So you have machine coordinates, and then you have your work coordinates. So your work coordinates are where you start from your stock, your wooden stock, and you'll zero the machine to your stock coordinates, and that's where it'll start to run the G code from. So you have like two kind of coordinate systems going on the machine at one time. So it knows where it itself is relative to the machine, and it knows where your work is relative to your work. So with that, hopefully that all makes sense, or at least the basics, and we'll kind of learn a little bit more as we go into the software side. So really the software that I use most is Fusion 360, and that's where I do all of my CAD, all of my CAM. So CAD is the actual modeling and design work, and then the CAM is the actual G code, building the G code and setting all that up. So your computer-aided manufacturing. And then once you have the software, then you can kind of export your CAM is your G code. You'll export that, and we will go into the hardware side. Just a quick kind of basics of the hardware rundown on this machine. We have this box of electronicals. This is the power switch over here. We also have a power switch here. So there's two power switches for the machine that need to be turned on before it's used. And then inside, this is the controller we're using. It's this STB4100. This is actually a controller from SainSmart, which is some electronics manufacturer. And this was kind of a kit we got from them to put this together, or at least the controller was. And then, so the controller is USB driven, so it'll actually be run by Mach 3, but Drupal CNC is another CNC control program we could use. So just another G code interpreter. Basically, it will take the code from there and it will program the movements for all of the motors. So your X, Y, Z, A will be all of these motors here. So like the Z motor is on top here. Your X motor is on the back of the machine here that runs along this bar. And we actually have a dual Y motor configuration for this machine. So there's one motor here and one motor here. And these are all running on NEMA 23 stepper motors. So this A motor is actually programmed to just, it's plugged into this pinout, but the software is duplicating the output for Y on both of those channels. So it just sends the same signal to two motors using two separate drivers. So the other thing is we have our inputs. The inputs are just switches. We actually do have an e-stop over here now that I did install recently. And then we have limit switches on the machine as well. So if it machines all the way to the edge, it triggers a switch and that tells the machine there's something wrong, it needs to stop. And then there are some output channels we're not using, and we do not have an MPG hand wheel, which is like a fancy CNC hand controller to really like just move the machine around. And those are the basics. We don't have any spindle control either. We just have this router on top over here, and you just turn that on and off. We could upgrade to some kind of spindle later on if it's getting a lot of use, but really probably not worth it in the grand scheme of things at the moment because we need it to be used and we need to generate money to pay for that. And then we'll go into some Mach 3 stuff. So again, this is the G code interpreter. There's a couple of basic G code commands here, and I have a document that I'm putting together with a bunch more training material, which basically has a few websites that will give you a lot more information on all this stuff. But we'll go through the basics of loading G code and things like that into this. And then the basics of how it works. So big reset button is the same as e-stop, which basically just tells the machine to stop until you figure out what's wrong. And then you can reset it to keep it moving again. So when a limit switch is triggered, the reset will start flashing. We won't see a lot of those features, but we'll go through how to load all the G code and things like that. So with that, I think it's time we jump into some Fusion 360. And we can go through some basics of a model I have prepared. So let's see. Someone was requesting hangboard stuff. I think it was Tal, and I think I saw you in here. So this is a really poorly designed hangboard I made a while ago that I've been wanting to machine for a while, just to kind of put the machine through its paces. So the basics, we have our design file here. I'm just going to turn some things off. And this is basically just a rectangle with some cuts and holes put in, nothing too fancy. Like I started with a block, I added some holes or chamfers and put some holes in it eventually, which must be this one. So like, and then just mirrored it across. And I definitely won't go into a ton of Fusion 360 stuff because this is a whole nother thing that takes a long time to learn. And there's a million videos on YouTube, which I highly recommend watching. So once we have this, just mirror that and go to the end. So once you have a model, and you can also download models or DFX files or like anything 2D and extrude it and put it into things. And we'll do a quick run through of that as well. So once you're kind of in this design thing and you've made your design, you're happy with it, everything's good, we will jump into the manufacture tab over here. This is the thing we care about because this has all the CNC setup stuff in it. And it actually means setups. So I'm going to just fold these down and start some new setups. So we'll just start from scratch. So when we do a new setup, it basically means like a collection of operations you want to run on the part. And you could put like all your tools and everything into one setup and that'd be fine. It would just, the CNC would require you to change tooling depending on what you're cutting. So the other thing you have to realize is like, depending on how we're going to cut this out, we might need several different tools and several different operations and several different orientations. So for this first setup, we have our setup here and the machine. We don't really care about that. We're just going to keep it blank because it doesn't really matter. We're not doing anything special, really. We are just milling. That's the important thing. And then the work coordinate systems. For myself, I always choose select Z and X-axis, just because I know that this will fit along the CNC. I mean, we could machine it this way too. But we know our Z-axis is going to be this because we're going to want to pocket this out first. And then we know that here's our coordinate system that we saw earlier, and it's putting our origin in the middle. So we know that we've selected our Z-axis. We already know that our Z-axis is wrong because we want to machine negative, and we want the arrow facing up. So that fixes that. And I actually don't need to select another axis because my X is along this way and my Y is along this way. And I know that this will fit inside the CNC already. So I'm just going to jump down to the origin is going to be a box point on the model. And I can click box point here. And I know that I want it here. So then that when I'm machining, when I go to the CNC and I set up my coordinates, this will be my 0 point. And then anything from there will be plus X, plus Y, and negative Z to do my machining. So when I go into Mach 3, this is going to be the starting point that I need to reference the machine to for the wood that I'm going to cut out. Now the model, it's selected that already, so that's good. And then we can go into the stock. So if I had a plywood that I've glued up or anything for this, I would measure that and then I would put that in here and say like, it's a fixed box size of, let's say it's like, what, 650 wide, 70 wide, 70 deep, sure. And then the model position is also good as well because what you would really want to do is you could offset your model depending on where you want it to machine into your wood. So you could build your stock profile and then say your model position is going to be offset from Y, like 0. Or your Z height is usually the most important. So we could go offset from top and go, it's actually going to be 5 millimeters from the top. And then if we can jump onto our front view, we can see that it's now added everything to the top. So we know we have to machine off 5 millimeters. So if we had a flat bottom surface that we wanted to keep flat and we didn't want to touch, we could go offset from Z. Actually, no, we'd go offset from top and then we'd have to actually measure it out and be like, what did we say? Our Z height was 50 millimeters, and we didn't actually measure our model height, but we can inspect that and measure it. And we know that the actual height of this is 44 millimeters. So now we cancel that. Oh, I have to do my whole setup again because I'm an idiot and didn't click save. Damn it. The joys. But that's okay because we can do it really quick now. Z and x-axis, Z, flip, stock point over here. Everything else is good. And then the stock size, we will do stock offset from bottom 0. Yeah, we can just call it 0. Unless you wanted to choose fixed size. But usually I would go with a fixed size because I'm measuring whatever wood I'm putting in the machine. And it's just going to be easier. And then depending on how you set it up, we do actually want the Z model position offset from top. Should just be 5. Actually, it's going to be. And I realize I don't have my camera as perspective with ortho faces. This just allows me to see a flat 2D face whenever I switch to the camera view, which is good to see if things are aligned. So we know that this is flat with the bottom with a 6 millimeter offset. And that's going to be good for me because it means that really for this piece, if I'm chopping things off the side, I'm going to do it on the table saw. I'm not too bothered about machining those off if there's extra stock there, but I am concerned about the top surface being level, and I'm assuming I already have a level bottom, or I would have planed that earlier or something. So we can set that up and that looks good. And then first thing we would want to do is actually get to that level surface. So we will face the whole top. So there's a bunch of commands up top here. So these are all the kind of things you can do. You can do facing is just like a sweeping back and forth motion. It's really good for just leveling things. That's basically it. 2D adaptive clearing, and there's a bunch of other 2D operations. And again, there's a ton of YouTube videos on all of these. For this, like we just have these pockets here. I would just do a 2D pocket, and then there's a bunch of other settings you can do within them. And then 2D contours, just like, so pocketing is cutting cutting into stuff, and then contouring is just cutting around stuff. And then there's a bunch of 3D operations as well. If you want to do like fancy shapes or ramps and curves and all of this stuff. Honestly, I've never really used it yet. I just haven't had the time to experiment with it, and a lot of the stuff I'm doing is pretty simple. So we're going to keep it simple. It's way better. So let's start with a facing operation. So with the tools here, I actually built some tools into the tool library, but there is a bunch of basics. Basically, I have this brand new shiny surfacing bit that is redonkulously huge, which was also really cheap, which looks like this. And I got 2 of these, and so it's 57 millimeters wide, 15 millimeter cutting height, and then 55 overall. And so inside of Fusion, you can add those into your library. Now, is this tool selector showing up? I'm just gonna do this because it might not be showing up on the share screen.
Yeah, I can see the tool selector.
It is now. Yes, Tal?
Are those the only, is that the only tool bit available for the CNC at VHS?
No, it's highly recommended you get your own tooling.
Okay, okay.
Just because what tends to happen is people break bits, but I am putting together a collection of like usable bits for getting started.
Okay.
Slowly. So for instance, but one of the things you need to do is like learn how to put your bits into Fusion 360. So with this is just a surfacing bit I bought for surfacing a bunch of stuff, and there's a couple of them there. And basically you need it to surface the bed of the CNC before you mount stuff to it.
Okay.
So with this bit, I will just edit the tool, basically just putting in a general description. With the cutter, you can just put in what kind of cutter it is. So there's a bunch of different types like ball end, bull nose, chamfer, dovetail. None of these I'm going to cover because we're just not going to have time. But there's a ton of things to look up. But basically the number of flutes is the number of like cutting edges it has. So you'll see things with like twisting flutes up, and they might have like 6, 4, 8 cutting flutes. This one is being flat and two-sided from here. It just has 2 cutting edges. So there's just this edge here and this edge here. So that's a 2-flute cutter. Like, it's very basic. And then I put everything in millimeters and just built out the diameter, the shaft diameter, the overall length, and the shoulder length and the flute length, which are the same because there's no shoulder on it. It's like 90 degrees. So once you've done all that, the rest of these things you can basically skip. Feeds and speeds, we're not going to cover too much, but I kind of default to 500 millimeters a minute. And that may be super slow, but the machine is also super slow. So you want to err on the side of slowness. Otherwise, it'll just kind of skip or jump the belt or something. So once you've selected your tool that you have a library of, or if you find one that's already in their Fusion library, you can just select that. If you buy one that's pretty common, that will bring you to this operation. Coolant is if we're using like metal machining, so just disable it. And then again, your feeds and speeds. The spindle speed, I default to 10,000 RPM because that's basically what our the router is going to be spinning at. It has a speed wheel on it because it's one of those handheld routers, so we've just kind of like taped to the CNC. It's like 10 to 20,000, but I leave it on like a 3 or a 4, like on the lower end of the speed, and that usually is about 10,000 RPM and sounds like it's not going to hurt itself when it's cutting is kind of where I go. Because like too high, it's going to start burning into the wood, and too low, it's going to just sound kind of grinding. You want it just to be cutting nicely, and you want to get like nice big flakes and not just dust off the wood that you're machining. Surface speed, 1790. This looks a little high, but I'm just going to leave it for now because we can always change it later. Then the geometry. So this is going to be for the stock selection. So we have to select the geometry that we actually want to face. If I selected this, because this is our model, it's going to skip all of this, and we haven't actually cut that area yet. So what I did earlier was I jumped back into the design area. So in the model over here, we have our sketches. I actually built a sketch that is just a plane on top, just so I can select this stock selection, which guarantees me I'm going to cover the whole area. Because if I select this, it's just not going to machine or face the whole operation or face the whole top of the wood. So I can select this whole operation, this whole vector or sketch, this sketch plane on top that I just built a rectangle on top. And then we can go to our heights. The heights here are basically, if we jump over the ortho view, it's where the machine is going to put the tool between movements and start machining from. So the retract height is basically when the CNC is moving around between operations. So if it plunges into a spot, it will then, if it needs to go to a new spot, it can't just go directly there because it's drilling in something. So it will retract all the way to the retract height. Then it will move across and then start plunging down for the next cut or the next drill operation. So between operations, this will be the height. If you're machining something flat like this, and we only have this one operation, 10 millimeters is actually kind of high. I know that it's not, there's no other things in the way, so I can bring that retract height down. because we are kind of limited on like the retract height, depending on how big of a workpiece you put in there. Like if you put in something that's going to be like 50 millimeters or like quite a big piece of wood, you might want to reduce all your heights if it's going to be flat, so that way the machine can actually pass over the top, because if it tries to go to the retract height and it's outside of that Z height area, you'll trigger the limit switch and it won't be able to machine anything. So if you know it's going to be flat, you can kind of play around with these if you're finding this like you're kind of getting within the tolerances of the machine. So 5 millimeters, and then these from retract height, this is actually kind of relative to each other. So you could do it from the model top if you want everything to be based off one reference point. But basically these all build on top of each other. So it's 5 plus 5 plus 5 plus 5. Where were we? Top height. That looks good. And it will give you errors. Fusion will give you errors if things are wrong. Like if I put in like -10 millimeters, it's just going to tell me that that's wrong. So it's kind of good that it's not going to let you do something insanely stupid, but 5 millimeters here. And we can see that basically just keep the color order correct. It's like blue, blue, green, red. And then you'll see them, it like tells you pretty clearly what everything is. Then the passes. This is kind of the most important area, is passes and linking. This is where we actually program the machining. So the step over, we know that our bit is like 57 millimeters wide. So if we want to get a nice smooth surface, we should only step over half the diameter of the bit. So like we should just bring this down to like 25 or like 30. 25 is the step over, and that would be millimeters. Because our bit is so wide, we want to pass it like within half the width of the bit. And then our tolerance is 0.01. That's just how it generates the G-code lines. So the more tolerance, the longer the G-code will be potentially. But I don't think it really matters these days, unless you're like highly optimizing stuff or you're just cutting straight lines and you're not really too worried. Pass direction, 0 degrees is fine. Pass extension. So this is where you're going to be coming into like machining over your stock. So we didn't really need to build this like extra layer where I machined this like or put in this rectangle, because I was worried about this edge not being machined. We could have done some pass extensions, but it wouldn't have been equal because it still would have just done a relative. So it was kind of easier for me to just build in this rectangle and say machine all of this. Stock offset is similar. So we can say machine outside of the stock this amount. So distance of machining the boundary. So if you want if your code is close to your stock and you want to make sure it's flat, and you want to make sure it goes flat off the edge of your stock and not like get to the end and stop and you might have a little bit left over if your stock was like a few millimeters longer than what you programmed. So you might just use this to kind of cover some bases. And then our linking tab, we have preserve rapid movement. Honestly, never touched this before in my life. Just gonna leave it. Allow rapid retract, that should be fine. Keep tool down. So this will keep the tool down and avoids moving it up if the area next to it is about to be machined. That's fine. Fusion's really pretty good at that. But you potentially could cause some issues if you're not sure about how you've set up your code. Leads and transitions. So lead in entry, kind of just, I think it just kind of curves the entry for the cut a bit. So it just kind of, it dips in instead of going flat. For us surfacing, we could go in flat sideways, that would be fine. So we could turn this off. But by default, you can just leave it on, it's not a big deal. Also that we're machining from way outside where our stock will be. So when it comes down, by the time it gets there, it'll be flat anyway. And lead outs, so it's usually just nice to keep it on, especially with like smaller tool bits and tool bits that you might be using. And then we can press OK. So now we have our cutter over here and we have our path that it is generated. And we can, over here, this is it. This is our facing operation. I'm going to jump into this view. We can see it's just moving down and machining across. We didn't actually kind of specify our stock. So it looks like we're not machining into our, well, we are. Okay, so let's go ahead and simulate this. So if you right click and simulate, oh, there we go, it's showing our stock. So this will actually take quite a few millimeters off at a time. So now that we have the simulation up, we can start the simulation down here and we can see what it's actually going to machine. So it's doing a pretty hefty cut, and we can see that we're kind of engaging quite a bit of the cutter, not all of the cutter. And because this is a surfacing bit and our machine is pretty weak, I may want to do this in 2 passes or 2 layers, just because if this is engaging so much, there's going to be a lot of cutting force on the cutter, and it may break the cutter or throw the wood or just chip a bunch of stuff. I'm just not sure the machine is rigid enough to take that much of a bite out of the wood. But let's simulate it anyway. And then down the bottom here, you can actually speed up the simulation. So it cuts everything pretty nicely, and you can see the step over is about half of the bit. But
Luke,
yep,
how much of a bite should you take? We were looking at that going, yeah, it's a little thick. How much should you be taking?
that is a good question, Pat.
5 mils?
So let's jump into our passes, and we can hit this multiple depths. And for us doing a surfacing pass, yeah, like we can see what 3 mil looks like. Maybe 5 mil should be fine. Let's see, because I'm not sure how much we were taking at the moment. Like, is that going to be 2 passes? Yeah, okay, so that's 5 mil there, and that's 2 passes. And then we can simulate that, and we'll see how that looks. Like, that's pretty mellow. That's not a huge deal. And then we can just speed that up. And then the second one is obviously way deeper, and there's actually, you can just scrub through. So like, that's 5 mil. Yeah, we can probably get away with that for surfacing, but I know that obviously the first pass was real, like nothing. So we could probably like split the difference. If we're going to do 2 passes, we can actually bring this down and just say like 3 mil, use even step downs. And you know, if we can't do it in 1, we have to do it in 2. We may as well make it even for both passes. So like our first pass now is like this, and we can machine through that. And then our second pass is going to be the same. And it looks like, yeah, about 2 or 3 mil. So that looks great. I know that that'll happen with no problems. So that'll be step 1. Then our next thing is, we're done with that. We can just go back here. We will turn off our sketch for our plane surface. And then we can jump into some pocketing. Now, I did have all of these rounded contours, but that will definitely be a separate operation because we won't be able to do that with 1 bit. So we will go into a 2D pocket. And then again, we're going to need to select a tool. There's a bunch here. We know that it's probably just going to be a flat end mill that we machine down into this pocket with. Typically we have those like router 2 flute bits, and I have one in my library that I built earlier, which is a 6 millimeter, 32 millimeter, or 6 mil wide, 32 millimeter long 2 flute. So I can drop in that. And then spindle speed, surface speeds. Oh, so this surface speed is way down. Let's just go to 500 and see what happens. Again, all this stuff, kind of experiment a little bit with it, do some test cuts for sure. Just generate like one pocket, cut it out with some test or scrap wood, and like see how fast you can run the machine. Run a few different tests like values and see what happens. The worst with the wooden router CNC is like the belts might jump or stutter if it gets like going too fast, or you'll break a bit and you'll kind of know the limits. But, you know, practice makes perfect. So once we have that, we'll disable the coolant. So even if you have this on, it's literally going to do nothing because we have nothing programmed to use it. So again, doesn't really matter for the coolant. So pocket selections, just select the base of the pockets, go through, select them all. 1, 2, 3. So 10 chains, that looks good. Stock contours, I forget what this is. No, we are gonna ignore that. There's a bunch of things there. And rest machining, we're also gonna ignore that. That just basically is like, it will tell the machine if there's parts that have already been machined. I won't go over them if my G code's telling me to go there. It's just, it's speeding up the operation, but we know that that's not gonna happen here. Clearance heights and things, we've been through this, so 5 mil up top there. And then passes. For this, we are definitely going to want to do multiple depths because this is like, we can't just plunge all the way in here and just do one single pass. So we are going to want to do that. And our roughing step down. So you can do like roughing passes and finishing passes. And the good thing about that is if you want your wood to be smooth, or even with metal or any machining, you can do roughing passes and basically have like 0.1 or half a mil or even a millimeter like left to machine in your pocket. And then you can machine the whole thing really roughly and quickly, and then just go back through really slowly with the same bit. And that way it'll give you a nice smooth finish and a better like surface quality. So we will do multiple depths. We'll do 5 millimeters. Finishing step downs. Sure, we can do one. And that means that we will do a finishing pass on each step down. And stock to leave, we're going to turn off because that allows you, so this will give you a 0.5 millimeters, and then you could run this again. If you're trying to get like exact fits, this is where your stock to leave really comes in handy. Where if you want things to like push together, you might machine it. You'll have this set up with your stock to leave at like negative 0.5. And then you'll do a test fit. And if it's not fitting, you'll come back here and you'll just say like, okay, I can, then you would just go like 0, and then you would go like +5, and so on until you get your like exact tolerance that you find fits. But for us, this is not needing to be anything accurate. So we can do step down to 5 millimeters, finishing step down 1, and finishing step down at 0.2. That'll be the bottoming. We don't, okay, I guess, actually, yeah, the finishing step down, I'm not sure we really care about because that'll be for the surface bottom, and we really care about the surface walls. So I'm actually going to turn that off because we can do that. We might be able to do that in our linking tab. So then we have our linking, save distance, allow rapid retracts. Yes, yes, yes. Horizontal lead in, we're going to be fine with all of that. And you can change all this. So sometimes it'll do like, so actually we're going to do this helix, like in helical ramp down, because it's going to be a flat bit. We want to make sure it's always moving and not just plunging straight down, because that will gunk up the bit and not have a really nice cut. You can change the degrees of how the helix ramps in and the different ramp step downs and things. And there's a bunch of things you can change here. And if you have pre-drilled positions, so you could pre-drill holes. So if we wanted to hog out a bunch of this, we could plunge in with a huge drill bit and like just clear a bunch of material, and then we could just drop into those holes and machine these whole things out. We're not doing that, so we don't care. So we will just click OK and see what it generates. And then it's not until you can really see the code at first, or like see where it's going to be moving, that you can really make a best guess of what's going to be good. And again, like simulate everything because it's just so easy. And we can just see how the machine's going to work. So for instance, like this is where it's going to start the transition. It's quite high, but it's just going to waste a little bit of time, but it's not overly important. And then let's just speed this up. So it's just going to keep cutting out. So it does like a little helix ramp down and then pockets around. And yeah, that should be just fine. For this, we could just leave this as is and just speed through the rest of them. Yeah, that's not terrible. I mean, the only downside is it does say it's going to take, I think, is that 4 hours and 12 minutes? Or am I reading this wrong? No, I think that's 4 hours and 12 minutes. Rob, you laughing there?
I'm laughing at your 4 hours.
Yeah, we would speed things up a lot. But because there's so many pockets and we have to do such shallow step down, it's kind of a pain. It's not a fast machine. Like the only way we could speed this up would be in our step downs of just doing like, I mean, what's 10 mil? We could just double it. And then maybe potentially like with our helical ramp, like trying to speed some of this up. But even then, I don't know, you'd have to test a bunch of settings. And that's really what this is. It's just play around with the settings. Like can't do that much damage. And it really does take a long time to learn. And again, just always simulate. And if things look wrong, it'll give you a good idea of that. Oh, machining time, 1 hour 50. That's good. So we doubled our step down. So we're doing 10 mil instead of like 6. And that seems to help a lot. And yeah, I mean, if we're going slow enough, we can cut out 10 mil like depth of material. Okay, weird. Maybe it's sped up because it skipped some things. Nope. Okay, we're going back. All right, well, that's not terrible. Can hang out for 2 hours, that's fine. So now we have all of that done. We've surfaced it, we've pocketed. We would want to then actually concentrate on the top of machining these parts. Now for this, we're going to have to flip the part. So we're going to have to do a new setup. So we would just go here and go a new setup and start this kind of stock stuff again. But we know we're going to have a surfaced front area. We know the back area is going to be surfaced already. We don't really care about the sides. We haven't surfaced this area, so we would run maybe a surface on the top. So I'm just going to leave all this stock as normal because we've kind of been through all that. But the orientation, super important every time. So Z and X axis. So this would be our Z. And that is kind of good. And our box point will be here. And yeah, so we would just flip it up and then we could start machining from the top side. And we would have to have new work fixturings and things like that, like new ways to mount it onto the machine. But as long as this is over here and your X is here and Y is there, that's good. And of course your X and Y could be flipped depending on how you want to orientate it on the machine. And then we can just, I'm not going to surface this top area because I just assume I already did that, and go into some parallel machining. I haven't actually done a ton of parallel machining, but this is a way to do like kind of contours. Let's see if this works. So I'm just going to select this edge here, which actually, no, that's my entry position. I don't want that at all. Let's start from the start. So the tool bit, I'm going to pretend that I'm using that flat bit that I No, actually, I would change to a ball nose bit for this because we want it to be like a smooth kind of area. So I'm just going to jump into the sample tools and find something I feel is appropriate. Of course, this would have to be something I own or go buy, but let's go over here to milling. We want a ball end because that will give us a nice smooth finish. We could rough it out first and then do a smoothing pass, which would probably be ideal to kind of like hog out the material. So that's probably the best thing, is to do like two operations. So one to just like hog out staggering material and then go through with a ball nose or a ball end mill and like smooth everything out. So you don't have to put too much strain on these cutters because they have like a small cutting tip. So they're not really good for like hogging out material. But that being said, you can also just get big ball end mills and just cut the whole thing at once and not really worry, but expensive. So let's just pretend we have a 5mm ball end. And cutting data. Can ignore all that because it doesn't say wood, doesn't really matter. But let's pretend this is just a 5mm diameter. So it's kind of small, but that should be good. Spindle speed 10,000, surface speed 150, sure. That all looks fine because I don't really know, but I'm sure it'll be fine. So this for the geometry here, it's going to silhouette element box. So we can actually do a, yeah, we can do a silhouette here for this ramp. And then we can, there is a, actually that'll be fine there. And then because we want to machine this one over here, we can select this silhouette. And if we want to machine this area, I wonder if we can do that one too. So we can do all of these ramps and passes in one go. And that's the machine boundary. Now this will be tool center on boundary. That should be fine. It may obviously have some problems with these walls here, where the tool will be cutting like into this wall. I'm assuming they would have no issues with that. With a ball and mill, might have issues because sometimes the cutters don't go all the way up the tool. So we may need to like hog that out first and then come in with the ball nose. So we'd use like the flat end mill and like just kind of cut away this area down to like, or step it down. But let's see how this works. So selection, we selected our areas, our heights, which can put that down to 5mm again, mostly just because it's always set pretty high. Step over is 5mm and our bit is only 6, so we need to bring that down because otherwise it should be half the diameter of the tool. And we have a 6mm, so wait, we have 5mm, so 2.5. And the machining direction can be both ways. That's just fine. And a bunch of other things that I'm not going to worry about because let's just see what cheat code we get. So linking all looks good. All looks default. All right. See some issues there. We're leaving quite a bit. So we're machining across. We could change the machining direction to go down. So let's have a look at this simulation to see what it's actually doing. Oh, that does not look good. I don't think that cutter has that much cutter on it. This is a bad example of what to do with a ball nose cutter. So let's cancel that. But what we can do is we could potentially just flip the direction. And if we're cutting down, this is kind of a tricky piece because kind of like probably not the best idea to do it this way. So you know what? Let's just change it and let's just go back to our 2-flute cutter and let's just try and like cut out or rough out some of this material and see what happens. Now, there should be a way to change the machining direction. a 90-degree pass. There we go. And then we can simulate this. So this is changing to the flat end mill. And this is just to kind of like get rid of all of this material. Actually, you can zoom out, it speeds up. And you know what, that's actually probably better. And we could actually just put some step downs in here if we don't think that it's going to machine all of this, but we know that only half the cutter is engaged during these passes. And I think my flutes on the cutter are going to be enough to be able to do that. So I actually think that you might be able to get away with all of these cuts just in one pass because it's going pretty slow. So that's actually, yeah, that's good. And then honestly, I would just do some hand finishing after that. And the other thing I might do is because we left these little lips here, assuming we've surfaced the piece already, because we have the 1mm stock set at the moment, and it doesn't know whether we've surfaced that or not. We could just run a quick surface on top of that if we wanted to clean it up. And then that would be it for the hangboard. Like anything else could just be a quick cleanup by hand and you'd be good to go. So we have a facing operation on this front side, pocketing everything, and then flipping it, setting the new origin point, and running some parallels on the top here. So after we've done all that, we would need to generate the G code for everything. So now we have like all our operations. What you can do on each operation is right click and go post process. And this is going to be generate our G code for everything. And the only thing we really need to know is the configurator is just going to be Mach 3 mil. So we can just go here. I'm going to go CNC basics, give it a name, which will be facing op, and hit OK. And then it's going to generate all the G code here, which is actually not that much, which is good. And by default, it usually opens it in Notepad or something. We can just close that down. With Fusion 360 and the hobby license or whatever I have, you can't have multiple operations with different tools in one setup. So if I tried to export this whole setup as one machine, like G code, so if I go post process here, I just found this out yesterday, and if I just go here and I go post, yeah, warning, personal use, you cannot post operations. So you used to be able to do this, but if you're doing a tool change, you can take the time to load some new G code, so it's not really a big deal. So for instance, we have this surfacing bit, this would be in the router, and we would have to change to our pocketing bit anyway. So we can post process this separately, and we'll just call this pockets. And Mach 3, throw in an output folder, and post. So this will just give you some .tap files, which we're then going to drop into Mach 3. And the parallels here, we can just post-process that. And this will just be top side. Okay, that is our G code generated. Now that we've kind of gone through all of that, let's load some Mach 3. So this will be Mach 3 loader. So basically you would grab your G code, put it on a thumb drive, bring it to the CNC machine, and then start setting up the hardware side there. First things first, we'll be hitting the reset button. And then this is the terrible 90s interface that you all have to deal with. We can start by loading our G code to make sure it actually gets in there. The facing operation that we just generated was there. So let's load this .tap file. And boom, we're here. This over here is our G code viewer, this sweet 3D renderer. So that looks like that, and it's showing all the lines, and basically the G code we saw in Fusion. And you can double click if you get lost, and it will reset that view. Important things, you have a cycle start, a feed hold, and a stop button. So stop will reset the, or stop will stop the machine completely. Feed hold will pause the machine where you're at, and cycle start will start the machine. So if you pause the machine, you can continue it. So feed hold and then cycle start to continue it, and stop will stop it altogether. You'll need to actually reset things. And this giant reset button also acts as an e-stop. So e-stop button is pressed, and that just stops the machine moving anywhere until you worked out what happens, or dealing with something, or if it's about to hit something, you can hit this button. We have hardware e-stops as well that you can hit, which will trigger this as well. And then all of the limit switches will also trigger this, but it will say limit switch pressed right here. And then you can just reset them here, reset the error codes. Setting up the machine.
Do any of those buttons actually turn off the steppers, or they'll stay locked?
Everything stays locked. So the only thing that will turn off the steppers is going to be this power button here on the bottom right. Everything else will just freeze, lock up the motors. Which is kind of important, because if you turn off power to the machine, the control card still gets power from USB, so it's still interfacing. And then, so if you turn off power to the machine and you can move the motors around, they won't know, the machine won't know it's been moved. It's a dumb machine in that kind of respect. Yeah. And then if you turn it all back on, everything you will have lost your coordinates, but the machine won't know that. So if you start machining stuff, then you're going to be like machining into the walls or machining into the edges of your material. So like if you've turned off the machine and you've moved it in any way, you have to then rehome the machine, or at least reset your work. So homing the machine is actually really simple now. There's this big ref all home button here. Now, if we click that, it's going to do nothing in this software, but on the machine, it will actually auto home. It will home itself to the limits, and it will move itself. So the best thing to do is actually to move the machine as close to the bottom left corner where we talked about that origin point, over like here, where it's going to be the limit switches will 0 to, and then hit ref all home, and then it will slowly move to the limit switches and then move off them. Same process 3D printers do when they're homing. So kind of exactly the same process, and that will give the machine coordinates. So if we hit machine coordinates here, this is now zeroed itself with this ref all home button. And then from there, we have our working coordinates, which is our X, Y, Z here. And you can use the keys to drive it around, and that will tell you where this is relative to your G code. So all of this is like, it thinks our G code is basically outside of the machine coordinates, because our homing position, well, our work 0 is actually like over here. So we need to then zero our workpiece to where we want to actually put it on the machine. So kind of confusing, but ref all home to home the machine. And then we need to set the work coordinates for where we have our stock. So you would drive the machine to the stock box point where you have your work. And then we could machine or set the 0 coordinates for the working coordinate system, which we would just do 0, 0, X, Y. And then if our Z is the right height, we would do that. And then we can regen the toolpath over here, and that resets the toolpath to that 0 coordinate system, or that, yeah, the stock box point that we set as our 0 coordinate system. Hopefully that's not too confusing. So once that's all done, basically if everything's set, our tool's in there, really we could just start. So definitely regen the toolpath each time, because I never trust Mach 3. It's always a good idea. But then once you're ready to go, you would turn on the router and then just hit cycle start, and it's going to run through all of your G code. And then go through, sweep back and forth, and then we can jump across to this toolpath tab over here. And these are some different views of Mach 3 with a bunch of different things. And it's telling me it's going up, and then it's moving down to actually start the machine path. So this is your Z height, or the machine of the cutter. And Other things, if you have written your G code and it's going way too slow for what you think, this feed rate, you can do an override here. So feed rate override, you can just drag that up and we could like speed it up by 250%, and that will just speed up the machine. So sometimes you're like, wow, I really did like make a mistake and this is running way too slow, and I think I can go a lot faster without causing any problems. You can do a feed rate override, and especially if you're surfacing stuff, you're usually not going to have any issues. You'll start hearing it if it kind of is going a bit weird, and you can always drop it back a little bit. And then again, if we hit feed hold, it's just going to pause the machine there. It's still going to keep running. And then if we want to continue, we can just hit cycle start to continue it. And it'll just pick up where it left off. Some other useful things, if we kill this, we reset it, and we stop it, we'll have to hit rewind, Control W. Rewind is to go to the start of the G code again. And the other useful thing is if you are halfway through a machining operation, something happens, something went wrong, and you have this huge G code file, and you don't want to have to start from the start again. Like let's say we had a couple of those pockets machined. So let's just load that G code. Show us pockets. So let's say we machined three of the first three pockets, something went wrong. We broke our tool bit and we had to start it again. We could scroll down the G code list and we can see over here where it's up to. So we would scroll down 1, 2, and let's go to there 3. And we can just kind of scroll back through the G code and it'll tell us what's highlighted or where the machine is. So, and usually like a Z11, we know is a Z move. So it's going up before it's going across. So we know that this across move and this Z3 is going to start going down to get ready for machining. We know that this is going to the next pocket. So we have our X, Y, Z, -35, and then it's going to Z11. So we know it's going from the pocket all the way to Z11. So we could set this as the next line, and then we can do run from here, and that will calculate all the previous moves, and then it'll say running from that coordinate. So we can do that. And then if our machine is still over here and we hit cycle start for preparation move, it will move the machine to that area. Now, I've had a lot of issues with this. If you're not close to where it needs to be, or if you're too far down, or you're not high enough, or if not far enough up your machine, it will just translate across typically first before it moves up or down. So it's very easy at this point to machine into something if you're doing a big translation move that isn't part of your G code, because it will just try and work out how to get there. So we hit cycle start, it'll say, here's your preparation move. So it's actually telling me it's moving to -35.4. So this is a huge no, because it's going to the one before. So I actually need to select the line after where we're at Z11, because -35.4 is going to be into the workpiece and it's going to move across. And so it's going to, this is exactly what I'm talking about. It will machine all the way through my workpiece at -35. So I'm gonna not do that. And I'm gonna click the next one after I hit stop. And we're just gonna, 421, set next line there. And then we can go run from here. And then we can see press cycle start. So the preparation move is Z11. Good, so we know that we're actually doing this move where it's already outside of, it's already above the workpiece. So it's super easy to think, oh yeah, Z11, it'll just be there. But no, it actually goes from the previous one and then just will machine through anything and then move up. But we want to do this, so now it's just moved its way across here. You can see that in the toolpath, and it's like getting ready to do the next move, which is move across. And then start going down. Just when you hit cycle start, it shows up automatically. So it's just a pop-up that comes up. So if we reset and we stop and we rewind, and we just go to 421, and then you hit the run from here, it goes through the G code to get, oh, okay, nope, I've hit the wrong things. 421, run from here. Okay, it's not liking that. Okay, run from here. It generates, and then it says press cycle start for preparation move, check the spindle. So you would want to turn the spindle on now manually, and then you just hit cycle start and it comes up with this and it generates that for you. And then you can hit like start spindle as if we had the spindle controller and stuff, which we don't. You just make sure it's on and then hit OK. And then press cycle, and then once it'll move to that next location, and then you can actually start machining from there or start the G code from there. And then that's going to start and do its thing. And then while that's running, you can be chasing it with a vacuum cleaner to clean up all the dust, because we are still working on that dust stack select or collection system, which I think is almost done. And with that, we've machined some things. And only 10 minutes over time. Now, questions. Basically, then cleaning up everything would just be, yeah, you can just stop it. Once it finishes, it'll usually go back to the home at the end of the machine or code. But usually, sometimes it does weird moves at the end of G code. So depending on what it's trying to do, like, actually one other quick thing is some G code basics, which is like the G90 move command. So let's say if we go G90X0, oh, here's this thing that came up earlier, RIJK words all missing. This means that it was like, I've stopped the machine halfway through a move, and you can reset it with G00, G00, and then we can do a G90X0. And that is like just telling the machine to move from where it is to the point X0. And then, so G90 is absolute positioning. So G90X10. So you can see this X move over here for 10. And then there's G91, which is relative positioning. So if we go G91X10, it will add an additional 10. So it'll move to X20. Or 10 mil where it was. So especially if you're trying to find like, you need to move down 1 millimeter and you can't really do it on the controller, you can just do a G91Z -1. And that will help just kind of dial things in, especially if you're like trying to set your stock height and things like that for where the tool is about to surface into something. You want to make sure you get the surface right. It's just a nice thing. You can just be like, oh, I'll just keep doing this until I get to the right point where it's just cutting the surface or touching the surface. I think I'll probably end up putting in a surface or a tool probe, sorry, where you can actually press a button to set the tool height, where it will just machine, or the bit will go down and you'll be able to work out the actual tool height. But that's to do with offset stuff, which we won't cover right now. But yeah, that is your basics on how to CNC. Probably a little long-winded, but hopefully that all made some amount of sense. Questions?
Hey Luke, can you hear me?
Mm-hmm.
Okay, can we actually download a copy of Mach 3 for practice before we start making chips?
Yeah, of course. You can just do that from their website.
Okay, it's free.
You can get a free demo version. That's what I'm running right now.
Okay.
And you can definitely load your G code. You can do everything I was just doing without any issues.
Okay.
I would definitely recommend that.
Is there any machine specific things we need to set up when we do that to kind of mimic what we've got physically in the space?
Actually, no, nothing, because we're running stock everything. The only thing that will be different is just kind of the way, because this is the controller for the machine. So all of your loading your G code, your simulating the G code in Mach 3 is all going to be identical. It's just how it interfaces with our machine is kind of all the stuff we touch on the back end to make it work, like the tuning of the motors and things like that, which
Gotcha.
You don't need to know, which is great.
Great, thanks.
I have a question. Can you hear me?
Yep.
Are there limitations to the types of profiles that you can mill on the CNC that we have at VHS? Like, can you do rounded profiles if you wanted to have something with
Yes.
curvature? Is that possible?
Yeah, so that would be some of the 3D profiling
Okay.
that is part of like the Fusion setup.
Okay.
So that would be all of this stuff where we could do like your scallops or contours or
Okay.
a morph spiral, which is I've never seen. But yeah, you could totally do that.
Cool. And we can use any program that generates G code, right? Like if
Yep.
we're not restricted to Fusion 360. Okay.
No, there's a ton of other ones like VCarve and some other easier ones.
Okay.
Fusion is just what I know, and just probably, yeah, it's complicated, but it's a lot of options there.
Okay. Cool. Thank you.
Hey, so I got a question.
Yep.
This is Hans, not Kendall. So you mentioned that so this session is really just training to get people up to speed, but doesn't qualify you to use the machinery. What's the scheduling for that step if you're there yet?
So there's a few final tweaks to the CNC router that we're making, getting a new computer next week, so we'll settle that up. So probably about 2 weeks away from doing one-on-one training sessions with people. And then that money will go to VHS and to initial investment tooling for people to use.
All right.
And then, yeah, we can get people certified. And yeah, really need the one-on-one, basically just to actually go over the hardware side of things and make sure that the safety stuff is kind of enforced.
Right.
And hopefully if people, because all of this is like the one-on-one stuff, I didn't want to cover all this precursor stuff because this is the important stuff. The actual, if you know all of this, the setup and use of the machine is really easy. And obviously this is the best way to teach a bunch of people at one time at the moment.
Yeah, cool.
Yeah, I just wanted to say thanks, Luke. This is pretty amazing, setting up this many people and getting them all on board. So it's a big plus, and hope to see lots of people getting to use the CNC.
Me too. It's been many years in the making. Don't build your own CNC, guys. It's a terrible idea. Unless you want to learn lots or way too much. Thanks, Mark. Cool. Well, I'll give it a minute for any final questions, comments, anything other than that.
Are you going to Hackspace tonight?
No, it's 8 o'clock. It's past
Yeah,
my bedtime. Well, with that, everyone, thanks for joining. I will post this video somewhere, and I will hopefully post some training details for one-on-one sessions to get everyone up to speed. Definitely practice all of this stuff. This is important. And definitely, if you have a project, bring a project for training sessions or anything you want to work on. That definitely helps because that will kind of keep the interest high for everyone involved. Thanks, everyone.
Thanks, Luke.
All right, thanks, Luke.